All right, we're going to continue our discussion on angles and circles. There are four main types of angles and circles. The first two we have already talked about. The first one was central angles, and remember, a central angle equals the arc that it intercepts. We've also talked about an inscribed angle. An inscribed angle, the angle equals the arc it intercepts divided by 2. Today we're going to talk about two more types of angles that are created in circles. Angles created by chords, and we'll talk about the formula a little bit more in just a minute, and angles formed outside of the circle. And there's the formula for that as well. Okay, so since we've seen the first two, let's go straight to number 3, angles created by chords. Now remember, a chord is a line segment that has its endpoints on the circle itself. So in this diagram, we actually have two chords. We have a chord right here that goes across, and we have a chord right here that goes across. And when these two chords intersect each other, they create some angles. Now notice that the vertex is not on the center of the circle. It's kind of floating out here in another part of the circle. It could be anywhere, but it's definitely not in the center. So these are not central angles. But what they do create is vertical angles. You can see that the two green ones are congruent to each other. Those are vertical angles. And the blue ones are also vertical angles. Okay, so that's kind of important to know. All right. So the blue ones are congruent, the green ones are congruent. Now, even though the angles are vertical angles and they're congruent, the arcs that they make are not the same measurement. They could be, but they're not necessarily. Like in this example right here, we have two arcs that are created. We have a large arc that's created on the left, and we have a small arc that's created on the right. Now this could be flip-flopped. It just happens to be this way in this diagram. But you definitely have two different arcs that are created when you have the chords that intersect like this. Okay, so the formula for this is that the angle measure equals the average of the arc measures. So in other words, the angle is going to equal the sum of the arcs divided by 2. So you're going to take the two arcs and divide them by 2. And that's going to give you the angle measure. Now, you always have to have three pieces of information: the angle and both of the arcs. The divided by 2 is not going to change. Generally, they will always give you two of these pieces of information, and you're going to be finding the third. So in this example, we are trying to find the measure of this smaller arc. They give us the angle, they give us the larger arc. Okay, so since we have these two pieces of information and we need the other arc, we're going to plug that into our formula. So the angle is 25, the larger arc is 35, and we're going to add that to our smaller arc, which we'll call x for now. The first thing you're going to do is divide both sides, multiply both sides by 2. So you get 50 equals 35 plus x, and then simply subtract 35 from both sides, and you get the 15 equals x. So x is 15 degrees, and that is the measure of our arc. Let's look at another example. So if I have this example right here, now I'm actually looking for the arc itself, and they have given me both of the arcs. Okay, so we're looking for the measure of the angle given both of the arcs. So remember, our formula is the arc plus the arc divided by 2 equals our angle. So this one's actually pretty straightforward. It's actually a little easier than the other one, because all I have to do is say 10 plus my 70 divided by 2. So that would be 80 divided by 2. So my angle equals 40 degrees. Pretty straightforward, not a whole lot of math to do there. Okay, so that's angles created by chords inside of a circle. Now let's talk about angles that are created outside of the circle. These can be created a few different ways. But generally speaking, is this one right here, in this example right here, these are two secants. Remember the definition of a secant. It's a line that intersects the circle in two spots. So this is a secant and this is a secant. Now, we're looking for this angle out here that it creates. You'll always have, because you have two lines, you'll always have a small intercepted arc and a large intercepted arc. The larger intercepted arc is always the one that's farther away from the angle. So the formula here is a little bit different. Instead of adding the two arcs together, we're going to subtract the two arcs and divide them by 2. So that's the biggest difference. When we had chords inside the circle, we added them together. But if it's outside the circle, we're going to subtract them and divide by 2. And that's going to give us our angle. Okay, so this angle always creates two arcs as it intercepts the circle. The far one is always the larger than always larger than the closer one. Okay, so we have 3 different types that we're going to talk about that can be made. We have one with two secants, like the example. That would be example A here. Okay. You could also have one made with 2 tangents. Remember, a tangent is a line that just touches the circle in one spot. So this would be an example of a tangent and another tangent that creates an angle. Okay, you can see that the difference of the smaller arcs is closer to the angle and the bigger arcs are farther away from the angle. I highlighted them in blue and green. The third type is one where you have one secant and one tangent, and that would be like in example number 3 right here. So I have one secant, that's this line right here, that actually creates a diameter. And it doesn't always create a diameter, but it does in this example. And it also is created by a tangent. So together this tangent and the secant are creating this angle X right here. And you can see it still makes a small arc, which is close to the angle, and a larger arc, which is farther away from the angle. All right, so let's see if we can solve these 3. So let's look back at example number 1. This was the 2 secant one. Now remember, our formula is the larger arc minus the smaller arc divided by 2 equals your angle. Okay, so in this one, just like in the chord one, you need 3 pieces of information. You need a large arc, a small arc, and an angle. Generally, they will give you 2 pieces of information, and you're looking for the third. So if I look at this one, they're giving me the angle, which is 10. They're giving me the smaller arc, which is 25, and I'm looking for the larger arc, which is x. So I'm going to plug that information into the formula. X minus 25 divided by 2 equals 10. The first thing you're going to do is get rid of this 2, because I don't want a denominator. So multiply both sides by 2, and you end up with 20 equals x minus 25. And then subtract 25 from both sides, and you find out that the larger arc equals 45 degrees. Now let's look at one where you have 2 tangents. So this was our example B, where we have 2 tangents. The larger arc is not given in this example, so we have to figure out how we're going to represent that. Okay, we're looking for the smaller arc, but I know in this one, the smaller arc plus the larger arc have to equal my entire circle, so that would be 360 degrees. So we're going to let the larger arc be 360 degrees minus the smaller arc, which is our x. So 360 minus x is going to represent our larger arc. We're going to use the same formula we did above. This formula doesn't change. We're going to take the larger arc and subtract the smaller arc from it, and divide it by 2, and that's going to equal our angle. And they do give us our angle. So this is what this is going to look like. The larger arc we said was going to be 360 minus x. So this represents our larger arc, minus our smaller arc, which is our x, divided by 2 equals our equals our, oh, I see a mistake I made there, equals our angle, which is 70. So let's see if I can correct that as we go. Yeah, that's going to equal 70. Okay. All right, so since I did that, the first thing I'm going to do is I'm going to multiply both sides, or no, I'm sorry, I'm going to combine like terms. This minus x and this minus x become minus 2x. The next thing I'm going to do is I'm going to multiply both sides by 2. So 2 times 70 is actually 140. All right. So now that brings us down to step 3. 360 minus 2x equals 140. And then the last thing I'm going to do is I'm going to subtract 360, and that actually does not end up being that. That ends up being 140 minus 360 ends up being negative 220. And that's going to change my final answer. So now I have the negative 2x goes here, the negative 220 goes there, and all I have to do to figure out what x is divide both sides by negative 2. So divided by negative 2, I get x equals 110 degrees. So I made a mistake, but I fixed it, and that's all good. All right, so the larger arc equals 110 degrees, which means the smaller arc would have to equal 70 degrees. No, I take that back. The smaller arc is 110 degrees, which means the larger arc would have to be 360 minus 110. So the larger arc up here, which they didn't ask us for, they only asked us for the smaller one. The smaller one equals 110, which means the larger one has to equal 250 if they had asked me for that, because those two answers have to add up to 360 degrees. Okay, let's look at one more. The last one is one that is created by a tangent and a secant. And in this example, the secant creates a diameter. Okay, it doesn't always, but in this example it does. You can see that it also makes a small arc and it makes a large arc. So it looks like they've given us the large arc and we're trying to find the angle. So we have to figure out how are we going to represent our small arc. Well, our small arc, we know that together with the large arc form a semicircle, so that's 180 degrees. So we can take 180 degrees, subtract this 120 from it, and that gives me the small arc. So that means that the small arc has to be 60 degrees. All right, so I can use my formula. The formula hasn't changed. It's still angle equals large arc minus small arc divided by 2. So in this example, the large arc we figured out was 120. The small arc we figured out was 60. We're going to divide that by 2. 120 minus 60 is 60, and 60 divided by 2 is 30.